Hello.
Hello.
Hey Terry, hey Jesse.
Hey, good. How you going?
Good. I invited a few other people, but well, they might turn up a bit later. Um, here we go. Raul, he's from Club, and he's worked in R and various data science things. So thought a few other people would show up this week, Terry. Maybe before we start, um, people could introduce themselves a bit. Um, so I know all of you, but Terry, tell Jesse and Raul um, the stuff you've been working on and about you.
Yeah, okay. So I've been involved with um, Jenkins X for a while now as a contributor, and I've been putting together the MLOps components within Jenkins X, and I'm also driving the MLOps roadmap within the CDF SIG. So, we're trying to get to a point where we can have a clean description of all of the features that we need to have within MLOps as a methodology, and paint a cleaner picture of what implementations need to consider and what features they might benefit from including.
And I guess Jesse, you're on my right on the screen up there. So yeah.
Yeah, hey, thanks for the invite. So I'm just know Mike through the startup community. So I'm founder of CodeLingo. So we're interested in basically getting insights out of source code, and just have a general interest in ways to improve the productivity of developers and development teams. We don't actively use ML or AI in CodeLingo at this stage, but we certainly have in our future roadmap. And yeah, thank you for the introduction, for the invite. I'm super interested just to keep an eye on this space. And I was reading through the CDF README. And it's just really helpful to get a bit of clarity around these definitions. And it's lovely to be at least a fly on the wall in a think group like this, because I think it is, I really love a lot of the points that was made in that README. And it's just lovely to get a bit of clarity around the terminology and the problem space. Yeah.
Oh, and Terry, do we need to because this is part of the CDF, do we legally need to say anything that this is being recorded? Well, it is being recorded. Surprise.
Yeah, so all of these sessions are automatically recording. So I don't have any control over the startup of this. It's set up by the CDF, automated for us. So we're.
And the CDF for Jesse and Raul's benefit is a sub foundation of the Linux Foundation. So the sort of fairly big in the open source community, and a sort of a very, very small sister of the CNCF and other things like that. So Raul, do you want to mention some of interesting stuff that you've encountered in the past? It sounded like you were pretty interested in the roadmap here.
Yes, so I started with machine learning some years ago at Atos, working on the first implementation of the data analytics as a service. So that was the first times of Hadoop, and now yet Spark streaming was very, very recent thing, not still production ready. And basically, as a developer, I fall in love with these kind of new challenges that machine learning took for me to build something useful. And after that, some years ago, I started also at Cloudbees, where I am working on the more DevOps side of things. I'm on the productivity team, so I'm very involved in releases, pipelines, that kind of things. And now when Michael told us about this, I thought like, oh, I can get a past amazing thing and merge with a current amazing thing, and it also makes a lot of sense. So it was like love at first sight, and my interest comes from there. I see a lot of challenges, a lot of amazing things that can be done, and it's quite interesting for me. So that's the reason why I'm here. And thanks, Mike, for the info and the invite.
Yeah, so I got interested in this through talking to Terry, and I guess my day-to-day interest is in applying some of this stuff. So I'm a bit of I think the word is dilettante with things like this. Like I dabble in things and I've used different libraries and tools throughout the years, but lately I got my hands on a lot of, we started collecting a lot of data for Jira issue tickets and, you know, sort of DevOpsy data. So I've started looking at things that we can do by analyzing that great, you know, those great big chunks of data and making predictions. And that was kind of interesting. And I believe the industry is sort of settling on calling that kind of stuff AI ops. You might hear the term AI ops thrown around. Whereas ML ops, as described in the sort of the roadmap, which Terry largely authored, is more about the application of data and models and deployment of models and governance and all that sort of stuff, sort of the parallel to DevOps. It's not so much about what you can do with ML or AI, it's more about how you get to production and then after production. A lot of stuff around pipelines and that. So I think that's pretty much an accepted definition, but part of the idea of sort of this special interest group is to narrow down sort of that definition a bit. Because like Terry's mentioned, there's interest from all sorts of interesting companies. Like I think it was Intel you were mentioning, like some of the people working on, or maybe you could talk about that, Terry, briefly.
Yeah, well, obviously this is an area that lots of companies are very interested in right now. They're obviously with machine learning applications in production environments, but in the majority of cases, they are having to treat those things as special cases within their overall software development lifecycle. They're often having to build their own platforms to allow them to deploy those assets, and as a result, there's a lot of bespoke technology out there right now, which doesn't sit cleanly with the sort of the rest of the learning experience that we've got from 70 odd years of software development experiments and learnings. So there is a lot of interest in bringing machine learning back more in line with the rest of our software asset management approaches. Transfer a lot of knowledge that we've gained from that software space back into the machine learning teams, who typically tend to come from a maths background rather than a software engineering background. And in many cases, they've never been exposed to the types of challenges that we face daily in trying to run software in production environments. So yeah, there is general interest in trying to solve these problems, hopefully in an open and generic way, rather than yet more layers of incompatible standards and products that won't work together.
And that's what we sort of went over last week. There was in that document, there was a table towards the bottom, and the first thing we talked about was sort of the role of notebooks. So I think this week we're going to move down that list and talk about handling data and stuff. I had a few other things I wanted to just bring up that I thought would be interesting just quickly. So one was this library that TensorFlow has. I've mentioned it to Terry in an email called AdaNet. Just pasted in the chat if you can see that there. I came across that because I was using a service that used it under the covers. And I was curious about it, so I started looking into it a bit more, and I thought this is, like Terry talks about, you've got data scientists that are whipping out R code or now Python code and slapping it in notebooks, and then you've got engineers trying to bring that to production, but this is almost the inverse, or the yin to that yang, of you might have developers that, in my case, have access to a lot of data. I'm not a data scientist, I can do the training courses, and I knew a lot of that maths once, but I find tools like this interesting because it's like, it removes me from twiddling too many knobs with the hyperparameters and things like that, or even choosing, you know, how many layers and things like that. It's a tool that it uses machine learning to select a reasonable approximation, or not approximation, but which model to use and how to tune it. And I've had some pretty good early results with that. So I thought that was an interesting tool, and I mentioned it to Terry as something we could add one day to sort of the library of quick starts, so that when a developer comes across this, they can go, oh, I can format my data this way, and I can normalize things that way, but I don't really want to learn about all this stuff. We don't have data scientists on staff. So I thought that was an interesting tool and something that Google are investing in. So it's called AdaNet, and it uses a neural network to train other neural networks, and even ensemble. They call it ensemble when you got a bunch of different algorithms or different types of neural networks sort of glommed together. And that's something that's usually hard to do just because of the sheer permutations you can try. And so this works if you've got a good, like you might not have data science, as much data science experience, but if you can throw computers at the problem in massively parallel scale, then you can have it try a bunch of permutations for you. And I thought it was a fascinating idea. And with sort of, you know, the cloud having lots of stuff on tap, it's starting, I think it might take off. So so that was an interesting one I wanted to bring up. Yeah.
Sorry, can I just throw a thought in here? Do we have an overall mental map to help us position these tools and the different activities in the life cycle? So what I'm thinking of, just putting my traditional software development hat on, we've got the old SDLC, but it seems like there's a similar life cycle that needs to be acknowledged when we're looking at integrating models into production services. And that's everything from, you know, your initial idea to actually building the model, tweaking the model, and then deploying that as well. And I imagine there's a whole set of tools and mental models to help us grapple each one of those stages. Sorry, I'm coming into this cold, so I'm just wondering, has any work been done on kind of the equivalent of an SDLC lifecycle map to locate?
I think Terry had some good diagrams. I don't know if I saw it in a pull request or a chart of you, or a slide deck of yours or something, Terry. I'm sure I saw something.
So there
fly past in the last week.
There are some documents. The Linux Foundation also has an AI SIG, which is incubating a series of machine learning based projects. And so they have a map of all of the projects in their ecosystem. I don't believe there is one overarching map that gives us a good picture of everything in the MLOps space today, but certainly it would be worthwhile to try and aggregate something like that.
Sorry, just to clarify my question, it's not so much getting a map of all of the available tools out there, but if I understand correctly, part of the mission of this group is to help software developers use, we're really talking much more about the actual kind of art or craft of using machine learning and trying to bring that into the space of more traditional software development. And so I suppose what I'm thinking from the software development standpoint is it's a bit like, what would you say? I don't know, almost like a kata if you're learning a martial art or something. You know, you kind of start with some kind of basic structure or outline, and okay, there's 1,000 different techniques you can do. There's 1,000 different things you can learn, but there's some kind of, and you can choose not to follow it or not. But I think what's lovely in the software development scene, we've got things like CD has arisen as a concept, and CI has arisen as a concept. And for example, code lingo, we're trying to get across this idea of continuous integration, which is another story. But I'm wondering if there's some, and of course, stop me here if I'm railroading, but if there's any work being done on, again, some kind of equivalent to an SDLC to help guide best practice. Let's put it like that. Like, what is the recommended best practice steps? Sorry,
so if I put my Jenkins X hat on,
yep.
What we're doing in that space is creating a series of reference projects as quick starts. So for each type of machine learning problem that you want to tackle, there is a reference example, and you can fire up a new project based on that reference example, and you will get a complete set of running code with all of the steps built in, showing you how to train that type of model. And then you can just iterate around that, gradually modifying it to match the data sets that you've got and the approaches that you're trying to derive. So we're doing it in a kind of opinionated way that works out of the box. So the amount of knowledge that you need to have to get something running is minimal, and then you can have your learning experience by tweaking an existing project and bending it until it does what you want it to do.
I guess Jesse's sort of asking, like, how do you, like, if you use one of these things, how do you step back and see the big picture of like what's a training stage of a pipeline? What's the input to the training?
That's it. Yep.
Where you know, if you were to draw a left to right sort of, you know, we like to do that sort of DevOpsy flow. Like, where do the data scientists live? And, you know, things like that exist, I think. Sorry, Terry.
So the challenge with that at the moment is that, you know, there is no standard way of doing that. And
is this an opportunity for us to spearhead that? And is that appropriate for this? Again, I'm coming in cold, so sorry if I'm being.
So yes, to an extent, but actually what we need to do is we need to demonstrate that there are ways of adding value to the machine learning ways of working that exist to date, without constraining those systems too much. Because, you know, part of the challenge is that we can't say, here's the best way of working in the machine learning space, because it's a technology that's in its infancy, and we have no understanding of how it will actually turn out. The techniques are evolving so fast that it's very difficult for any one person to keep abreast.
Yeah, I think Jesse comes from probably a similar position to me, where it's sort of the developer angle of, here are the things I know, what are the things I don't know, whereas the more sort of pressing problem is what Terry's saying, which is, you know, from the notebooks and data science angle, because that stuff's already happening. But maybe like just a dictionary somewhere would help, like a dictionary of definitions. Like, training is like this, its inputs are these, its output is that. A pipeline for a machine learning sense is this. A model is a deployable, you know, what even is a model? Like, that's something that a lot of people, in fact, probably even data scientists, don't really know under the covers. Like, it's like, well, a TensorFlow model is a bunch of config files and a binary protobuf file. Like, you know, maybe there's a space for some definitions like that, but that would I kind of just keep that in my head. I just sort of look things up.
Are there gotchas at each one of these stages that would be helpful to communicate to the community?
I think for developers, for sure, like, you know, models could be big. They might go on a phone. They might go on a service. There's a lot of code that goes into massaging data before it goes into a training stage.
Mm-hmm.
And you want to, you know, when the training outputs a new model, you want to do the CD kind of rollout thing with that, just as if it's, you know, a jar file from a Java compiler. There's a lot of things like that. From the data scientist point of view, it's in some ways it's more complicated because they kind of don't want to know that. So that's kind of what, like, part of the challenge is to educate them. And so, and Terry's solution to that, because he's working in this domain, you know, with sensitive data and data scientists, is to sort of give them these rails to ride on. It's like, well, create things this way and you'll have a repo with this in it. You'll have a repo with the service in it, and things will work together nicely. You just ride the rails. Okay. Thank you. Cool. I got a beer. So.
I've got some tea.
Yep.
So, well, what if it's all right, Terry, what if we jump to that, sort of what we were doing last week, which is jump to the technology requirements section of the roadmap?
Yeah, sure.
So I'll paste a link to that in the Zoom chat here. Because that might help explain things a bit. So last week we talked about educating data science teams regarding the risks of Jupyter Notebooks in production. So have you heard of Raoul and Jesse? You've heard of,
Yep, had a little play.
Yeah. So it's and there's a change pending for you know, a pull request to change that. So I guess we could move on to the next.
Yeah. So let's just cover off that piece of old business. So you questioned the phrasing around that.
I think I might have misunderstood. Let me open that pull request. It's that pull request there. I pasted in the chat. So you wrote that Jupyter Notebooks are the tool used to train data scientists, as they can easily be used to explore. Like, don't data scientists use Jupyter Notebooks, not the other way around? Or...
So no, that's not giving me what I expected.
It's not merged.
I was expecting that link to take me to the.
Oh, you're not logged in, maybe.
That one.
Mm-hmm. Fast change. Yeah.
Can't see under here. I want to see the home. Right, that's better.
What I believe we are dealing with here, is I have felt in the past some sort of impedance mismatch when a data scientist is talking with a developer and vice versa. So the feeling I have when you were discussing this thing is we are having that exact problem. It's like, are we talking to data scientists? Are we talking to developers? Are we talking to both? And this connects to what Jesse was talking before, I believe. So maybe some sort of impedance match between terms, vocabulary, needs, and that kind of things may make this more readable for both sides. I don't want to talk about sides, but it's true that in my experience, how data scientists talk is different on how developers talk. And if we don't have a clear common vocabulary, easily understood by both sides, it's not going to be as clear as it could be.
So yeah, I think you're right in that, but I think we also have another problem here, which is just a habitual one. So typically the universities are using a limited set of tools to teach machine learning, and they're doing it from an academic perspective. So what they teach is what you need to do to get an academic understanding of machine learning, but they don't teach any of the practical elements of how you use those assets in the real world. So as a result, you see everybody being taught to do machine learning by using a Jupyter notebook. Everybody thinks that Jupyter notebooks are machine learning.
Oh, I see your phrasing now. Sorry, I understand your phrasing now, Terry. Yep, makes sense.
So maybe I should expand that a little bit to make that clearer. But it's a little bit like the problem we've had.
I was seeing the word train and thinking training model. You literally mean data scientists learning how to do machine learning.
All
so
right,
I see the word train and I think model.
Right.
But yeah, it's I understand now.
Yeah, let me change that to educate, and then that will be clearer.
Right. Yeah.
So because we saw the same problem with the university. So initially everyone was being taught to program in C, and then we had to retrain everyone when they came out into industry, and then the university switched over to Java, and then everybody gets trained to be a Java developer, and then you've got to retrain them again when they come out into industry.
And somehow
and
no one
situation
in the
here.
process.
Sorry, I missed that.
And somehow no one learns Git when they go through uni.
Yeah,
I don't know how they missed that.
Yeah. So I am regularly encountering data scientists who refuse to use source code control with their models because actually it doesn't work well with things like Jupyter notebooks. So it's an impedance mismatch, and so they push back against it. So what I'm suggesting here is that we're using Jupyter notebooks today because they're familiar, not because they're the best tool for the job. And actually the fact that we're using them in production environments is more an indication that there's a huge gap in the market for the right tool, rather than any strength of argument to say that they're doing a good job in those production environments. The reality is that Jupyter notebooks are very inconsistent. You can execute part of a program in a Jupyter notebook and get a result which is complete nonsense because you only executed part of your notebook, but it will still give you a result, and that result is meaningless. So there are lots of examples where you can draw bad conclusions from looking at a notebook, and ensuring consistency is quite hard to enforce in that environment. So the point here is really that what we need to do is flag the fact that other tools are needed, and encourage people who are working in those spaces to develop their capabilities to support the MLOps standard with their tooling. And obviously the likelihood is that we are going to see things like Visual Studio in introducing new functionality that is better aligned to supporting data scientists. And at that point, probably Jupyter notebooks will go back to being a more niche desktop product.
Yeah, when I see Jupyter notebooks, I see literate programming, and I can understand why, because when there's a lot of, people like to say 80% of the work is massaging the data and preparing it, and there's a lot of things you do, because I just do it in code and put comments in there, and you can't remember why you did it. Whereas when you flip it around in where the comments are rich and first class, and the code is little paragraphs, like literate programming is, then you've got this big trail of why you made that decision to drop that column, or why you normalized it in a certain way, because that is a lot of machine learning. So I can appreciate how it got where it was, but it doesn't mean it's the right, it's the name notebook implies that it's, a little book of notes that you have on your desk, not something that you would put in production.
Yeah.
Exactly. It's like,
so I guess sorry.
It was just, it's like works on my machine, works on my environment,
Yeah.
but it's not a production ready. And the problem is many data scientists believe ownership ends when their Jupyter networks work, but that is not deployable to production.
Right.
That is not production ready. Exactly. Yeah, I fully agree.
Yeah. So
I guess
a lot of this is about extending the definition of done to an MLOps scope, rather than just a data science experiment scope.
So one, I guess looking at the next thing down, in fact, the next few things I think are all related, like treat ML assets as first-class citizens, DevOps process, providing mechanisms by which training sets, training scripts, and service rapids may all be versioned, how they're auditable across their life cycle, training sets as managed assets. To me, sort of the overarching answer to jump to a solution is what people call GitOps, I guess. Like every, and I'm sure Terry would probably agree, every change is like a change in a Git repository, be that on a branch or a pull request from somewhere to somewhere else. Everything that happened is, a commit with a SHA and all that sort of stuff. Like that's kind of, to me, that's the overarching answer to a lot of these problems. If it's done right, because it's worked so well elsewhere in DevOps, like it just makes sense, don't you think?
Yeah, and perhaps we should start by clarifying what the process is that we're doing.
Right, and what the yeah.
So if you've had a chance to look at the document, you'll know that it's broken into sections, and we have the challenges section, which is just spelling out what the high-level problem that people operating in this space are encountering. So we've mostly fleshed out this section. I think we have a fairly broad coverage of a lot of the key problems in this space right now. So what we're doing from this point on is working our way through each of these challenges, which we've already spelled out, and then looking at the technology requirements that are brought up by those challenges to try and spell out how we might develop new capabilities to address those challenges. So what we're doing is collaboratively fleshing out this document to increasing levels of detail, so that we're telling the story of our thinking processes, which can then be shared across the whole community. So anyone interested in building a product in this space has got a very firm foundation to work from, and also where we're looking to build standards-based methods for solving some of these problems, we've got the evidence to argue for a particular standards approach.
That's really helpful. Thank you.
And you are completely free to contribute to any of these sections ad hoc. We don't have to go through this in sequence. I would really welcome people just going through the document and submitting
pull request, isn't it?
PRs
We still,
to them.
yeah.
Yep.
So if you feel there are things that you can contribute, then feel free to fire me a pull request. It's just a markdown document. The only thing that's mildly complex to manage is these tables at the bottom, which are a little bit of a hack to get them to display in GitHub. But you'll see from the repository how that works.
So I was planning on doing a pull request or two, but one thing that would help me would be if we could enumerate sort of what the type of assets are in the machine learning pipeline. I think I know, but I'd like to talk through that if we had time. I'm just running a bit low on time.
Yeah, sure. I mean, and maybe what we need is a glossary section.
Right.
In here, we have got a section for references, but if we want to explicitly pull out a list of key terms, then that would be the place to add that.
Just take a note.
And this table at the bottom we'll probably work on later in the year, because once we've got the list of technology requirements, then we can properly evaluate what work is already going on in those spaces and where we've got big gaps. And this paints the picture of where we are against the roadmap.
Is the impedance between the software developer and the data scientist just terminology, or is there also a philosophical difference there? And would it be useful / appropriate to have a crack at addressing that? Because I'd certainly be quite interested to see, Terry, how you see the world from your perspective. And I could certainly give it a crack, kind of how I could see the world from a software developer perspective.
So yeah, I think that's an interesting one, because it's not going to be the same everywhere. But I think there are some extreme examples where, I have seen entire departments where everyone is a data scientist and no one has done any software development. And then they've spent several years building a bunch of models, which they've been then completely unable to put into production environments because they got to a certain point and then they don't have the ability to actually build all of the services and web pages and everything else that sit around that to expose it as a product. So
I'm just thinking that as an example could be like one potential difference where we were talking earlier about, the works on my machine experience with the Jupyter notebooks and that kind of N of one proof point. Right? I feel it's quite a common, it's almost a religion amongst software developers that the code doesn't work unless it's tested. So there's this kind of really drilled into us, the importance of unit tests and integration tests. And just because it works for you there does not mean that it, by any means, that it's done or it works. And I wonder if that's different in the data scientist community.
Yeah, I mean, that's a good example. So there are certainly situations where people are not giving consideration to the right level of testing on models. So the challenge is that the headline statistics on a model tend to be things like accuracy. So the types of testing that are done by default are often more about measuring the fit of the model to detecting the features that you're, rather than the overall reliability and consistency of the model against an extreme set of real-world challenges.
Yeah.
However, that is changing as it matures, and we are starting to discover new types of testing challenges. So there is a whole area of adversarial processes where you're deliberately generating inputs into a model that make it do things that you want it to do against its intent. So, you know, there are a lot of people working on, you know, tweaking images in such a way that they cause a model to recognize something that isn't there. So that's one of the fields of testing that we do need to consider. And we also have a lot of awareness around things like bias and fairness, where we need to be able to establish that the decisions that models are making are not, you know, inherently biased in some way, and that they act with you know, reasonable levels of fairness across the populations that the model is intended to serve. So we are introducing a new level of testing complexity into the problem space, which introduces a new set of challenges in terms of how we actually test for that. So partly this question does need to discuss how we treat machine learning assets in respect of things like unit testing and integration testing, but also how we extend those paradigms to cope with, you know, things like detecting ethical problems or bias. I think there are some sections further on that, in fact, I need to update this table because there are some additional things in here. But here you can see we've actually got a challenge section specifically on testing machine learning assets. So we should probably start to expand on there. And if you want to have a think about that and contribute some thoughts in that area, then feel free to do so.
And one of the reason this stuff sort of comes up, it's quite topical in the news, like people will say, well, how does the model explain how it made a decision, which is never easy to do because they're often a black box. It's not, but that doesn't necessarily mean it's impossible. It's the same if you wrote a lot of you know, messy code with if statements and loops and stuff,
right.
And then it makes a decision to approve a loan or not. How do you explain that? Yeah, Jesse's laughing because you know what I mean. Like, yeah. All real production systems are built under duress that way. But the reason is you can trace back through the changes in the code and who approved the pull request. Was it covered by testing? Did the testing cover these scenarios? Did it have acceptance testing? And, you know, it's kind of the same thing. If you can do all that with the model, it's not like you have to crack open however many layers of neurons it is and then say it went here, and like that doesn't make sense. It's more like, you know, what set of data trained it? Can we reproduce it?
And part of the challenge here is that there's a trade-off between explainability and privacy, because the answer to why did you make this decision may come down to because of this piece of information I got out of Michael's bank account.
Right, and or it's a whole lot of people's bank accounts that were trained to this model to spot fraud, and you can't just go, well, here's the corpus of data that we trained it with because that's privacy, you know, that's got private information in it. And I guess the reason it impacts here more this than with regular spaghetti code is often this stuff is applied to like approvals or decision automation or image recognition and things like that. So it just tends to get applied in more sensitive ways because it's solving sort of the edge of very, very complex problems. And not always, like it might be if it's a recommendation system or a movie thing, or it's going to suggest, in Jesse's case, it might be suggesting a fix for some code or a policy change or something like that, it's spotted you would work better this way. There's not really any issue there. It's like it's just a recommendation or a bit of automation. It's not. But in the grander scheme of things, it's super risky to not be able to explain things and trace it back.
The challenge,
which we do with source code, we do with source code. It's all the time. It's like a normal thing.
Yeah, I mean the real challenge in this space is going to be regional legislative compliance for these types of solutions, because everybody's scared of AI taking over the world, and AI can't vote. So from a political perspective, it's much easier to introduce legislation that protects human workers rather than introducing legislation that protects the capabilities that machine learning can bring. So we're already seeing a strong skew against being able to use machine learning solutions in certain territories, and that means that the standards that any AI solution will be held to will be much higher than the equivalent standard for a human worker in the same situation. So the expectation for AI will, in many cases, be unrealistic in terms of compliance, because we have no mechanisms by which we could prove the same thing with the existing humans doing the role. There are, in many cases, no good solutions to many of the challenges that exist in this table. But what we can do is help to spell out ways that begin to provide approaches to some of them, and just incrementally move things forward.
Maybe one way of phrasing it is that you're looking for fault detection. So the hypothetical is that the AI made an error. It did something wrong, and what you're trying to do is trace the source of that fault. And I think it's not so much about kind of opening up the brains and having a look at the neurons inside it, but if we could have some source revision around the dials being tuned and who tuned them, and good notes around why and the thought process at that stage, then hopefully that would give you the data exhaust that you could look at as a problem in itself to try to track back the source of that fault, the thread that led to the development of this model with the implicit fault baked into it.
Yeah, and I think maybe the best approach for us would be for everyone to just pick a topic area in here which interests them, reference back to the challenges table to understand what the description of the core challenge was, and then just write something up and that would be a useful contribution to this technology table. And you can do that and submit it as a pull request on the document, or you can just message me with some text and tell me where you think it's relevant, and I'll make the PR if that's easier for you. But I would just like to get more input into this document right now. We very much need to build this as a collaborative asset and get multiple viewpoints on it. So And I think we can use these sessions to then iterate over the contributions and make sure everyone's comfortable with the wording of them and refine them until everyone's happy.
I think that's good. Yeah. I've made a note to put some things in that are floating around my head. So I've got to get off soon. Just it's getting later. It's much later for Jesse, of course, but he's a night owl. Obviously, seems way too chipper for. Yeah. So yeah. Jesse's in New Zealand.
All right. Well, thanks everybody. That was a really useful session.
Yeah.
Just one super little quick point on the regulation. Couldn't we sidestep that, because that's more around preventing what the AI will do? And could we just say, well, that's not really a problem space for us. We're more about like fault detection versus preventing, anyway, maybe a discussion for another time, but I just think, that whole regulation.
My consideration in that space is that most organizations are going to be required to prove legislative compliance in their AI solutions, and they will want to include that in the governance processes for their software releases. So it really needs to be a feature of CI/CD platforms going forwards, that there are mechanisms built in that allow you to demonstrate having gone through that audit process.
A big red stop button on the back of the robot. Cool. Okay, thanks guys.
Good chat, and we'll probably do it at the same time in 2 weeks' time. It seems to work with people. We could do it a bit earlier if it works for others, but we can chat about that. There is a Slack channel as well, so if people want to join that for the CDF one, then messages flowing there. Yeah.
Cool. For me, this time's okay. It gives me a chance to get the kids to bed.
All right. Yeah, that's good. Yeah.
Yeah.
All right. Cool. All right.
Thanks
everyone, and till next time.
Cheers.
Yeah.
Bye.
Thanks.